All right, so chapter 1, section 2 is linear equations in one variable. Again, like I said, hopefully this is mostly review with a couple of like extra stuff that we kind of just push a little bit further. So solving equations, the first thing we're going to do is isolate the variable. There will be only one variable this time, but there could be more than one of those variables. So you might see an x on the left and an x on the right. Okay, it's still just the same variable. There are two special cases, and these happen if the left and the right side of the equation are equal, so exactly the same on the left and the right, whether that ends up being a 2 equals 2, or a 2x equals 2x, or a 2x plus 1 equals 2x plus 1. If it is exactly the same on the left and the right, this answer is all real numbers, okay? And it's called an identity. The second special case is if the variable cancels out and what's left is a false statement, then the answer is no solution. So if I have no variables left and I have something like 3 equals 2, that's obviously not a true statement. This would be a no solution, okay? Your WebAssign actually will ask you to write in the letters D and E for those answers, which means does not exist. But on most like standardized tests, multiple choice, that kind of thing, you're going to see NS or no solution or no real solution, something like that. That's it. Now we just do the examples, right? So we start with the easy stuff, like number 1, okay? I want to isolate the 3x first, so I do the opposite of minus 6, which is plus 6. 3x equals 6, and then I want to do the opposite of multiplication, which would be division, and I get x equals 2. The great thing about every single one of these types of equations is that they can be checked. So this answer can be checked by plugging it back in. I am not saying to do this on every question as you take your test because you will run out of time. But if you get to the end and you have the time, obviously go back and check. 3 times 2 minus 6 is 6 minus 6, which is 0. And 0 equals 0 is a true statement. Okay, number 2. I have 2 x's, one on the left, one on the right, and then I've got 2 constants, one on the left, one on the right. It doesn't matter in which order you do this, okay? I tend to move the x's first, and I tend to like to make them positive, but you don't have to do this. So I move the x on the side with the 5x. These cancel. This is 2x plus 4 equals negative 8. Then move your 4 to the other side by subtracting it, and I get 2x equals negative 12. Divide both sides by 2, and x is negative 6. And again, with extra time, we can plug them back in to check. This would be 5 times negative 6 plus 4, negative 30 plus 4, which is negative 26. And on the right-hand side, 3, negative 6 minus 8, negative 18 minus 18, which is negative 26. And negative 26 equals negative 26. So I know I did that correctly. So I have to look back on WebAssign and see. I will look back on WebAssign, but I'm pretty sure it will be like an x equals, and you will just enter in the answer there. So you're just going to give the numeric value like number 2 and negative 6. That's how it would be on a test as well. You don't have to write x equals. You can just give me the numeric part. Everybody good so far? All right, number 3. First step would be to do what? Good. I can either subtract 7 from both sides or add x. I'm going to subtract the 7. This cancels. I get negative x equals, this would be 12. And then I have to divide or multiply, because it both gets rid of it, by a negative 1 to get rid of the negative on front of the x, and I get x equals negative 12. And again, I could have plugged that in to check. All right, you do the right side. 4, 5, and 6. All right, so 4x should have been 3, 5x should be 3 over 7. I want you to leave it like that. I don't want you to try to divide that or use a calculator to get a number that has to be rounded. I want it exactly that way. And 6 is x equals negative 4. Everybody good? Yeah? Okay, great. All right, let's keep it going. Number 7 here, I'm going to subtract 5 from both sides of the equation. 5x, sorry. Then I get 2x minus 9 equals, this is gone, 7. Add 9. 2x equals 16. Divide by 2. X equals 8. Good morning. Thank you. Okay, now I've got the first one that has some parentheses. So what are you going to do when you've got a number on the front of parentheses? Good, distribute. So I'm going to distribute both. 6x minus 6 plus 4. Distribute here. 21x plus 3. I've got like terms on one side of the equation, so I'm going to combine these together, and I get 6x minus 2 equals 21x plus 3. Now, I like to keep my variable positive. It's not always possible, but I would probably subtract the 6x. You don't have to do it this way. Subtract the 6x. I'd get negative 2 equals 15x plus 3. Then I'd move the 3. Negative 5 equals 15x. Then I'd divide by 15. And I end up with negative 5 over 15, which this time can be reduced to negative 1/3. So x equals negative 1/3. Good? Yep. At home, we're still good? Okay. You work through 9. So again, distribute. And then do what you got to do. Sometimes you just got to close it out. Yep, mine happens every once in a while too. Everybody get x equals 26? Yeah, good. All right. All right, this one, number 10, still distributing, but this time on the left side, obviously, I'm going to distribute like I did before. 6x minus 12 equals 7. There is technically a 1 hidden here. When I distribute this, it's a negative 1 that goes to both. And that is probably the most common mistake made on stuff like that, is forgetting to distribute the negative to that positive 5. So make sure when there's parentheses that the negative on the front goes to both. So now I get 6x minus 12 equals 7 minus 5, which is 2 minus x. Then I'm going to add the x. 7x minus 12 equals 2. Add the 12. 7x equals 14. Divide by 7. And x is 14 over 7, which is 2. All right, 11 is the last one like that, so distribute the 4. This is negative 8x plus 4 equals 6 minus, a 1 is going to go to this, negative 1, so this is negative 2x plus 4. Negative 8x plus 4 equals 6 plus 4 is 10 minus 2x. This time I'm going to add my 8x. Again, you don't have to worry about the positive negative. I don't know. It's for me, I just like nitpick on that. Plus 6x. Subtract the 10. and then divide by positive 6. Good. X equals negative 1. Question so far? Feeling very confident right now, yes? Hopefully. Okay. So now we get into equations that have fractions on them. There's a couple different ways to approach this, but for me, if I could give you a piece of advice, it's the first step would be to get rid of the fractions. When you see, yeah, go ahead.
Can you just put x equals negative 1, or do you have to like variable equals x?
Oh, no, you can switch this around. Yeah. So Madison just asked, can I switch that around? And yes, of course, you can switch that around. Okay? It doesn't matter what side the variable's on. All right, so for number 12, like obviously I could distribute this in here and then work it out, try to find my least common denominator, go through that whole thing, okay? But for me, I would say my best piece of advice is get rid of those fractions as soon as you possibly can, which means I'm going to multiply the entire thing by the least common denominator. So my denominators are 5 and 3. What would be the least common denominator? 15. Good. So I'm going to multiply the left side and the right side by 15, or 15 over 1. Now this 5 goes into the 15 3 times. That 3 then will get distributed into the 2x plus 5. So I don't multiply what's inside the parentheses by the 15. What's inside the parentheses is kind of like, think about it's being protected until I distribute in. When I distribute, by making that a 3 now, it's going to change the equation the way that I need to. On the right-hand side, 3 goes into 15 5 times. So 5 is going to get multiplied by the x plus 2. With me so far? Okay, distribute the 3 in, 6x plus 15. Distribute the 5 in, 5x plus 10. And then I'm back to where I was before. Put both x's on the same side. Move the constants. And x equals negative 5. Just like before, we can still check these. Okay, obviously it's a little bit more work because there's fractions involved, but you can still check these answers by plugging that back in.
Wait, I'm confused how you got rid of the 1.
So this side, I multiplied by 15. Technically, it's 15 over 1, right? And it would be times 1/5 times 2x plus 5, right? So this is what I'm multiplying first. 5 goes into 15 3 times, and then that 3 is going to get distributed to what's on the inside. So the goal of that first step is to get rid of the fractions on the front. If you don't get rid of the fractions on the front, you did something wrong. Or the fraction on the bottom in the second one. Questions on that one? Okay, so again, they just get a little bit more complicated. Look at 13. I now have 4 denominators. I've got 3, 2, 4, and 3. I want to find the least common denominator or the least common multiple of these. Okay, so the easiest way to do it, there's a lot of different ways to do it. You can do factor tree, you can do prime, factorial, all that stuff. The easiest way to do it for me is take the largest number and find multiples of it find the first multiple of it that all the numbers go into. So they obviously don't all go into 4. 4 times 2 would be 8. They don't all go into 8, right? 4 times 3 is 12. Do all 3 of those go into 12?
Yeah.
Yep, so that's what I'm going to multiply by. There are 4 terms here separated by plus and minus signs, which means I'm going to multiply 12 over 1 by all 4 terms. I'm going to walk this through the first time step by step, but you don't have to do the step I'm about to do every time. So 12 over 1 gets multiplied by 2x plus 4 over 3. Then 12 over 1 gets multiplied by 1/2 x. Then 12 over 1 gets multiplied by 1/4 x. Then 12 over 1 gets multiplied by 7/3. Now I'm going to cancel. 3 goes into 12 4 times. 2 goes into 12 6 times. 4 goes into 12 3 times. 3 goes into 12 4 times. There should only be 1s in the denominator at that step. If not, you did something wrong. You didn't use the right least common multiple. Now I multiply it out. So 4 gets multiplied. Whoa. 4 gets multiplied by 2x and 4. 8x plus 16. 6 gets multiplied. Now all of this is a 1. So 6 times 1 times x would be 6x. Equals, all the denominators are 1. So 3 times 1 times x is 3x. All the denominators are 1. So negative 7 times 4 is negative 28. Now that purplish step, like I said, you don't have to do all the time. As you get better at this, I could say, okay, 3 goes into 12 4 times, so I'm going to multiply that. 2 goes into 12 6 times, I'm going to multiply it times that. 4 goes into 12 3 times, I'm going to multiply it times that. 3 goes into 12 4 times, and I'm going to multiply by that. So you don't have to do that step every time, okay? But if you know that you're like shaky on it, then make sure you write it out. Now I would combine my like terms on this side. 14x plus 16 equals 3x minus 28. Subtract the 3x. 11x plus 16 equals negative 28. Subtract the 16. 11x equals negative 44. Divide by 11. And x equals negative 4. And again, that can get checked by plugging it back in. Questions on that one?
So this whole lesson is like when, I don't remember what it's called, but it's like what we do all the time when you have to do, when you find the variable, but just with the properties we've already looked at.
Yeah.
So this is all the same thing, just applying it to what we already know.
Yes, ma'am. Yep, yep. All right, 14. Ew, I have a decimal and a fraction mixed together. Miss Chris Weiser, why would you do that to me? First of all, Miss Ferrier makes the examples, not me, so blame her. Second of all, it's going to happen, so might as well get used to it, right? The easy thing about this is 0.25 is an easy fraction, right? What is 0.25? 1/4. So I could just say, okay, I'm going to do 2/3 x plus 1/4 x equals x plus 2. And then I'm right back to where I was before. So if my denominators are 3 and 4, what am I multiplying this by?
12.
12 again. 3 goes into 12 4 times, so I'm going to multiply 2 times 4. 4 goes into 12 3 times, so I'm going to multiply 1 times 3. This is gone and this is gone. 12 also has to get multiplied by the x and by the 2. So do not forget to carry that number across the equal sign. That's one of the most common mistakes made with this stuff. So I would get 8x plus 3x equals 12x plus 24. 11x equals 12x plus 24. This time I have to move it, making it negative. Negative x equals 24. Multiply by a negative 1 or divide by negative 1. And x equals negative 24. Questions on that one? All right, now 15 just has your parentheses and brackets. So we're distributing right here, okay? We want to start innermost parentheses first. So that 4 is going to stay on the front. The bracket's going to stay there. The 2x is going to stay there. This negative is going to get distributed to the 3 and to the x. So minus 3 plus x plus 5 stays as is, equals negative 7x minus 2. Now I'm going to combine my like terms inside my parentheses. 4, bracket can change to parentheses or stay as a bracket. It doesn't matter. It's still just a grouping symbol. 3x plus 2. Now I distribute that 4. 12x plus 8. Add the 7x. 19x plus 8 equals negative 2. Subtract the 8. 19x equals negative 10. Divide by 19. And x equals negative 10 19.
What happened to the 2x and the 5?
The 2x got combined with the x to make it 3x. And the negative 3 got combined with the 5 to make it a positive 2. Was that you, Ethan? Are you good?
Yeah.
Okay. So on WebAssign, again, you can type that in. Obviously, the shortcut, remember, for fraction is I can do a negative 10. I can hit the little button on my keyboard that looks like this, and it will give me the fraction bar, which will make it a little bit easier to type in your answer, obviously, or you can just do your, grab the little equation editor, the fraction one, and type that in. But your answers will stay like that. Sure.
So when you multiply the 3, you have to do the x and the 2?
When you multiply the 3, you have to do it, which 3?
Like,
Here.
the denominator, so don't you have to find the denominator?
Are we talking first one? So this would be 12 over 1 times 2 over 3x, right? That 2 over 3x is one term. So then the 3 goes into the 12 the 4 times, and then I'd multiply 4 times 2x, which becomes 8x.
What was the answer for 12 again?
Oh, where did you get
The
the 12?
12 is the least common denominator of the 3 and the 4. So I converted 0.25 into a fraction, right? And then I multiply by the least common denominator. You're welcome. What'd you ask, Audrey? 10 over 19.
For 12?
Oh, 12. Balls. So I'm going to start with 16. Actually, I'm going to let you start. Go ahead. Work 16 and 17 out, and then we'll get to 18 and 19.
I thought the letter answers are
Say again.
like the word, like the first two, like when it like the word answers, no numbers.
When it cancels out.
Yeah. Like
Yeah.
Identity and then the end.
So I'm going to, the letters, like what you use? Yes. All right, so we're going to distribute this here, so I get negative 2x minus 8 plus 3x equals x minus 8. Then I'm going to combine the negative 2 and the positive 3, and I get x minus 8 equals x minus 8. So I can actually stop here because left side is exactly the same as right side. If you don't catch it, then if I add the 8, it cancels. I get x equals x again. It's still the same on both sides. Divide by x, subtract the x either way. I get 0 equals 0. It's going to continue to be the same on the left side and the right side, if it's this case. So this is my identity problem. This is all real numbers is the solution, okay? And on WebAssign, I think it says, let me check the way the wording is. It just says type in REALS, reals, like that. Everybody from home good?
It's like, because I remember, I think when we learned this, I don't remember what we did was, I can't remember if this was like the infinitely many solutions.
It's the same thing. Yep, infinitely many,
There was like
identity,
7 words
all
that
real
they told
numbers.
us.
They call it all this. It's all the same thing. Yeah,
I don't know why they call it 100 different things.
to confuse you.
Stupid.
Agreed. All right, so distribute here. 9x minus 3 equals 9x plus 7. So close to being the same thing, but the constant's different, so it's not. When let's say I subtract the 9x first, these cancel and these cancel, and I get negative 3 equals 7. Okay, and we know that negative 3 does not equal 7. So this is a no solution question. Okay, and on WebAssign, you will write it as DNE for does not exist.
If you subtracted not the 9x, but
If you did the numbers first,
yeah, I got 0 equals.
still false, right?
So does it matter which one you do first? Because I know some teachers do care
Nope.
which
I don't care what you move first, right? I get 9x, so, plus 9x. It's still going to cancel. And I get 0 equals 10, which is still false. You might get a different false statement, but it's still going to be false.
Okay, because all it's asking is like if it's false or true.
Correct.
Or true or false.
Somebody had a question?
For the test, can we just put false?
No. So if it's multiple choice, it will say no solution. And if it's open-ended, I want to say we'll probably keep it same as WebAssign just to be consistent. Maybe put the DNE. We haven't made that test yet. And then if not, we will tell you exactly what's right. Kind of like in the practice test you did yesterday, I told you write the words no solution. That you'll write that. Or NS or NRS, no real solution. I will tell you specifically what to put in that box. Because that would be a question in which, like short answer, I can get Canvas to grade that for me. Thanks, Angie. Everybody good? Moving on. Yeah, last ones? Okay. 18. I got a lot of distributing to do, and it's both happening on the left side. Doesn't matter. I'm still just distributing. So I'm going to distribute these to both. Negative 6 times 2x is negative 12x minus 6. Distribute a negative 3 to the x and to the 4, and I get negative 3x plus 12 equals negative 15x plus 1. Combine the like terms on the left-hand side. Negative 12x and negative 3x is negative 15x. Negative 6 and positive 12 is positive 6 equals negative 15x plus 1. Add the 15x. Cancels and cancels. 6 equals 1. That is not true. So I'm going to put DNE just to be consistent with what you have to do in the homework. Okay? Or no solution.
19? No.
Did it?
That's just where it stops.
Oh, I think that's the end of it, though. Let me look at my notes. I think I passed these. Yeah, that's the end of it. All right, got to the very edge of the paper on 19, but the only thing you're missing is the parentheses there. So here's what I would say. Look ahead into the next step to see what you want to do at the beginning of something that only has one fraction. If it only has one fraction, and that fraction goes in evenly to the numbers next to it on the parentheses, then just multiply it out. So 1/2 of 6x would be 3x. 1/2 of 14 is positive 7. That's less work than multiplying everything in this by 2. But if you do that, obviously it's going to cancel from here. I have to multiply this by 2. I have to multiply this by 2. I have to multiply this by 2 before I distribute it in. So if it's just one fraction and it goes in evenly to what's next to it, I tend to just multiply it out. It seems a little bit easier, not to say you can't do both. Okay, both are correct. All right, so now I get x plus 1. The 2 goes to both of these, plus 2x plus 6. Combine my like terms on the right-hand side there, and I get 3x plus 7. Look, it's the same. Catch it as early as you can. All real numbers. Or in WebAssign, the word reals.
I tried doing it the other way,
Mm-hmm.
and I didn't get that.
All right, so let's work through it.
Oh, I shouldn't have done it the other way because that was probably.
It's okay. You're bound to, we got to figure it out anyways, right? So 1/2, 6x, I would have done it anyways because somebody is going to do it the other way. Okay, so let's say we multiply everything by 2 to get rid of that fraction. It's gone from here, so I get 6x plus 14. The 2 goes to the x, so it's 2x. The 2 goes to the 1.
That's where I made the mistake.
Yep, there you go.
Mhm.
And then 2 goes to the 2.
So when you do it like that, so if it takes away the fraction in the first part, you don't multiply it by everything in the parentheses?
No, so you never multiply it by anything in the parentheses. Remember, what's in the when we multiply by the least common multiple like that, what's in the parentheses is protected. You don't do it until you distribute. So you're going to reduce it first, and then you're going to distribute.
Okay.
So I'd go 6x plus 14 equals 2x plus 2 plus 4 goes to both.
So it does make, it's just because I did multiply it by everything.
Yeah, no, you don't want to because you're technically changing the 2 into the 4 and changing what's on the inside. You can't do both.
So because it cancels, you only have to do it to the other side of the equation.
You have to do it to everything, but you only, so like you don't do it to what's inside the parentheses
For either.
for either.
Oh.
Yeah. So then I'll go back to the other one, I'll show you that. 6x plus 14, and again, this is all reals. So if I go back